Quadratic functions are pretty commonly tested on the SAT. A quadratic function has the standard form ax squared plus bx plus c, and the shape it makes is called a parabola. Now, of course, there are other forms of the parabola that we could be tested on. That is our vertex form, a times x minus h squared plus k, or we have our zero form that's factored out, right? That would look like parentheses, a pair of binomials being multiplied together. But no matter what form we are in, we could solve parabola questions pretty easily on Desmos. Let's take a look over here. What is the minimum value of the given function? So here we have a parabola in what we call intercept or zero form, right? That binomial pair over there that's been factored out. So we just graph that. So that's 2x, and that was plus 3, and 2x minus 5. So remember, most graphs on Desmos will have a couple of key points, right? And we'll have our x-intercepts, those are labeled over here. We have our y-intercepts labeled over here. And in the case of parabolas, we have our vertex, which, yes, is either your max or your min. In this case, the min we're looking for, which has an x value of 0.5 and a y value of negative 16. So we're being asked for the minimum. Our answer is going to be negative 16 over here. Now again, doesn't matter what format we have our quadratic function in. Here's a vertex form parabola. Negative 16 times t minus 1 squared plus 36 is the height of a rocket. At what value of t? So t in this case is our input. It would be along the x-axis. At what value of t does the rocket reach its maximum height? Now this is in vertex form, so if you recognize that, you would realize that t equals 1, right? Just from a times x minus h squared plus k, where h comma k is your vertex. But if we either forgot that or wanted to double check, we could just throw it into Desmos. Negative 16, and that is going to be x minus 1 squared plus 36. So squared plus 36. And we can zoom out to make sure that we see our maximum over there, and there it is, 1 comma 36. Again, t represented our input. That was our independent variable, so that's going to be 1. And they could give us more creative questions like this. When the quadratic function is graphed in the xy plane, where y equals f of x, its vertex is negative 2 comma 5. One of the x-intercepts is negative 7/3, 0. So this isn't something that we can necessarily solve directly in Desmos, but it's one of those examples of a question that's a lot easier to visualize, and because we have Desmos, we don't have to sketch out by hand. We can see what's going on over here by just graphing that point, negative 2 comma, that should be 5, and we'll label that. And then one of the x-intercepts is negative 7/3 comma 0. Negative 7/3 comma 0. So again, this kind of helps us visualize things a little bit, right? We know that parabolas are symmetrical. So if we have one intercept over here, the other intercept should be right around here. And we notice, oh, the x value of our vertex is negative 2 comma 5. The x value of our intercept, the one intercept that we have, is negative 2.333. Because parabolas are symmetrical, we should know that the other x-intercept is going to be 0.333 in the other direction. And which answer would that be? Well, it's not 1/3 or 7/3. Those are both positive numbers. So we can quickly check negative 13 divided by 3. And that's negative 4.333, so too far. And then we have negative 5/3, which we know is the answer at this point, right? Which is negative 1.666, right? Because if we did negative 2 plus 0.333, yep, that's about right. So not a direct solve, but again, just an illustration of how visualizing can help us solve parabolic questions. Let's try a couple more that are slightly on the more complicated side. So this is in terms of solutions. When we're dealing with solutions in a quadratic function, again, think of solutions as intersections. And when we have quadratic functions set equal to 0, that basically means crosses the x-axis. because that's basically where we are crossing the line y equals 0, which is our x-axis. So which quadratic equation has no real solutions? So mathematically, you would use your discriminant, negative b over, or opposite of b plus or minus root b squared minus 4ac over 2a, our quadratic formula. It's that b squared minus 4ac term, that's our discriminant. And if it has no real solution, our discriminant should be negative. Or we could just graph these all and see which ones do not cross the x-axis. So that's 3x squared minus 3. That does cross the x-axis. And again, we could just adjust these. So we have plus 3x is our next one. That crosses the x-axis as well. And then we add another plus 3 here. And that does not cross our x-axis. So this is going to be our answer, C. Now, even more advanced, the two solutions, again, so that means where it crosses the x-intercepts, are negative 3/4 plus the square root of 65 over 4 and negative 3/4 minus the square root of 65 over 4. And it's 2x squared plus 3x plus c equals 0. C is a constant. What's the value of c? So we're going to have to use a slider and play around with our values of c to make sure that we are getting the x-intercepts we want. So what we can do is just take a quick setup over here to figure out what negative 3/4 plus square root of 64 plus, and then this is going to be square root of 65, and this is over 4. All right, so that's 1.255, and we could just make this x equals that so that we have a vertical line there to make it easier to visualize. And then we could do another one. So again, this will just mark where our x-intercepts are, and that's just going to be the same thing, but negative over here. So we're going to get rid of that plus, make that a minus. And now we just need to make a parabola, 2x squared plus 3x plus c. So we got 2x squared. And then plus, and that was 3x plus c. We'll add that slider for c. And now all we have to do is just play around with c until we have our x-intercepts at those same points. So we could slide this way, and that's going up, not the direction that we want it to go. And we can slide back down this way, getting closer, getting closer, getting closer until those points overlap. And zoom in a little bit just to make sure. So again, moving away, and there we go. And that is where our points overlap when c equals -7.